Houston, we have a podcast. Welcome to the official podcast of the NASA Johnson Space Center, Episode 9, International Space Station Number 2, Research. I'm Gary Jordan, and I'll be your host today. So, if you're new to the podcast, this is the one where we bring on experts, NASA scientists, engineers, astronauts, and they tell you everything you need to know, all the coolest parts about NASA. So today we're talking about space station science with Tara Rutley. She's the Associate Program Scientist for the space station here at the NASA Johnson Space Center in Houston, Texas. And we had a great discussion about what kinds of research we're doing aboard the orbiting complex right now, what we're learning, and why it's important. So with no further delay, let's go light speed and jump right ahead to our talk with Dr. Tara Rutley. Enjoy.
Minus 5 seconds and counting. Mark. Launch commit light circle correct. Here she goes.
Houston, we have a podcast.
Well, thank you for coming on and taking the time to come on the podcast. I'm excited about this topic because, you think about the International Space Station, giant football field-sized spaceship, huge solar arrays, but you're like, that's cool, but what are they doing inside, right? So that's kind of what I wanted to talk about today, and you're the perfect person to do that as the Associate Program Scientist for the International Space Station program. So welcome. First thing I want to say, especially in your position, we do science, if someone were to ask you, what do you do? What do you do up in the space station? You would say, we do science. We do scientific research, correct? Am I fair in saying that?
Yes, and then they say, why? Don't we have enough laboratories on Earth? And then I say, it's this huge orbiting laboratory. Think of every experiment you've ever done in school.
Okay.
And, you can control temperature and lighting and all these different things, but the one thing you can't control is that you always have that gravity vector there. So now imagine any experiments you've ever done. I know, it's such a force to be reckoned with. Any experiment you've ever done on Earth, what would happen if you could take gravity away from that, and what would you learn? And then the light bulbs start to go off, and they go, oh, okay. And then the next question is, what we'll talk about for the rest of this podcast is, what do you get out of it?
No, that's perfect. I mean, if you can, there's always this, when you talk about scientific research, you have certain things that you just have to deal with, right?
Mm-hmm,
gravity, I think, would be one of those things. It's something you can't, it's a fixed, I'm sorry, I haven't taken a science class in a long time, but is it a fixed something and then versus a variable?
It's an independent variable. It's a fixed.
Okay, all right.
It's something that, it's something you can't change. So you can change temperature, pressure, lighting, humidity, heat, all those things. But gravity is, 9.81 meters per second squared, bringing you back a little bit.
All right, it's coming back.
And this whole planet, everything on it, every living system, every physical system has evolved around that gravity vector. So it's what we're used to. It's what we can predict our theories around, and it's what that's how we know what's going to happen next. But so when you go up and you try all these different science experiments in the microgravity environment, it's not always predictable. And that's what we want to use that environment of the space station for. Is like, what happens next if we send this up? And then, as human beings, we want to find out, well, how do we take that information and leverage it to our benefits, either on Earth or help us go explore further?
Yeah, no, that's a perfect overview. That's
great. You can tell I'm a station hugger.
Well, that's great. You're in the perfect position, especially if you're there. But so, what's something? Just as a general example, before we start to get going, what's something that you're like, hey, I wonder what would happen to this if we brought it up to what's like one of the cooler things that you can think of? What would happen to blank?
I don't know. I don't have a personal, my head runs through like all kinds of scenarios. So I've not been able to satisfy myself personally with what would happen within a particular experiment. But the one I get asked the most is about development. Development of, next generation of a particular living organism. And
living things, okay.
Yeah, like reproducing in space. And what happens with the offspring, and do they turn out funky or normal or anything like that? Ooh. So, we're not quite there, although there have been a couple of what we call model organisms that, fruit flies, for example, we can send up. and have reproduction, and then look at their offspring and look at anything different that might be occurring.
Yeah.
And so fundamentally, I think I get asked that the most because it's something we can all relate to. It's kind of weird in itself, but it's also like explains a little bit about who we are as living organisms in this environment.
It's so cool that we have a place to do that too. You have that question like, what would happen to if we were to have living things reproduce in space?
Yeah.
Oh, that's right. We have a laboratory where we can test. Yeah. That's really cool.
And it's I have to say, I've been a space geek my whole life, and I've watched all the shuttle experiment missions and the development of ISS, and being a scientist as I am, I have to say that now is the golden age for space research. More than ever before, and probably more than we'll ever see again. Now's the time.
Well, we got a gigantic laboratory to do it, so I can see why it's the golden age.
Yeah, so by the way, for anybody who's listening who's a researcher or a student, and you have an idea for something that you think you could do in space, we want that right now. We're out there trying to get the best to use this platform.
Ooh, okay.
Yeah,
all right, we'll have to,
stuff.
at the very end of the podcast, we do we pitch where they can go for more information.
Good,
so
I'll be happy to give it
I'll
to
make
you.
a note to say where they can go. Researchers. Okay, cool. So, one of the experiments that I always think about is, not necessarily experiments, but what would you want to send up to space that would look cool? And the pictures of water up there, they are just so cool. You think water splashing, maybe sticking to stuff, falling, waterfalls,
I love that.
but it doesn't fall. It forms into a ball,
Yeah,
right?
I love that. Yeah, so that's a great example. That's one of the most highly visible phenomena that always comes out of space station. And you're always seeing the astronauts play with it, mess around with it. But the really interesting thing about fluid behavior or water behavior in space is that for decades we've been launching to space, but we've never had any models, software models, or models of fluid behavior that based on the microgravity environment, that we could build predictions on. So, for example, if we want, fluid tends to hide, crawl up cracks and crevices in microgravity. On Earth, it's going to sit in your glass. You can stare at it and know it's going nowhere.
That's good. That's
good.
It's
good. Yeah, that's how we work on Earth. But in space, that stuff gets everywhere.
Right.
And you could potentially lose important parts of it. It's a precious resource, fluid in space, whether it's a propellant or it's water.
Right.
And so we have never created the most efficient propellant tanks, for example, based on the behavior of water or propellant in space. So we've had really one of my favorite experiments was a very elegant, simple handheld experiment developed by Mark Weislogal out at Portland State University, and he's a phenomenon with fluid behavior. And what we got from his experiments was a whole new set of open source code now, understanding how fluid behaves in space in different geometries of containers. So a square, triangle, honeycomb, whatever. He's got all those models. And now if you, as a researcher or anyone interested in building a propellant tank or a fluid tank for space, have a CAD model, you can go stick your design into that software program and see how fluid's going to behave in your system. And and so for the first time ever, we have these models that we can design more efficient propellant tanks, more efficient water handling systems. That's going to help us explore. But now also, because we are getting a better handle on fluid behavior in space, we're also able to apply it to ground watering of our agriculture. The way that plants take up water in the soil, it's all the same. It's capillary flow. It's capillary action, the way that water moves through a medium to get to its source. Because we took gravity out, we could really focus on looking at capillary behavior. And now we can apply it to ground-based watering systems. We can apply it to tiny little lab on chips, anything that uses fluid movement and you don't want to use a battery, you want to leverage gravity. I mean, all kinds of advancements are coming out of this simple, elegant series of research that came out of ISS. So it's really, really cool.
That's amazing. So going back, those CAD models, is that assuming your system is in a weightless environment, or is that for any system?
That's assuming that you're designing for a weightless environment.
I see.
Yeah.
Okay,
So
cool.
if you want to design for the next vehicle that that we launch to wherever, Mars or station or whatever. Or if you're a student and you want to design an experiment for space station and it's going to have fluid in it, you can take your model and stick it in there.
Cool.
And, yeah, see how it behaves. It's great stuff.
That's awesome. Yeah, I've seen some of those experiments too, and they're really cool. I mean, it's something you wouldn't normally think about. You put fuel in a rocket and then you launch it because the fuel's going to go to the bottom.
Right.
But in a weightless environment, it's not. It's gonna float around, and all of a sudden you got fuel coming out whenever it happens to smack that side.
Yeah.
But you got to figure out a path in the weightless environment to do that. Wicking,
Yes.
yeah, very cool. So another one before we kind of go on the overall kind of research kind of thing is, when I see fire in space, those fire experiments that they're doing, it's like a little spark, and then it just forms this tiny like faint blue ball.
Yeah.
So what are we learning from fire?
So another highly visual one, fire and water, and our basic needs.
Well, those are the first ones that come to mind, at least for me.
It's totally cool.
Yeah.
So we do combustion studies in space because when you take that gravity vector away, the way a flame burns, it's got lots of different layers, and it puts off lots of different particles, so to speak. And there are people who study that on Earth, like their whole lives, people are studying flames, just like those who are studying bubbles. Because we here on Earth want to learn how to better detect fires. We want to be able to better put them out.
Right.
But also in space, we want to do the same for different reasons.
That's fair, yeah.
And so how do flames behave in space? Well, we've been studying those for decades. In fact, way beyond, before space station even. But now we have this huge facility dedicated within the laboratory for ongoing experiments. And so, if you've seen the images, you said a little, the way flames burn in tiny little balls, blue, tiny little bulbs. You don't have that candle-like peak at the top.
Right.
Right? Because in space, there's no convection. There's no, think about it, there's no density. There's no mass. There's mass, but there's not relative density. So you can't have, on Earth, your hot air will rise in a flame.
Right.
And then the cold air will sink to the bottom and then rise up again, right? But there's no sinking in space. There's no relative densities. So you don't have convection. That's what that is. So now in space, you don't have hot air rising, and your flame burns in a little ball until it's extinguished. Now, a really interesting piece of that is we have found in burning some of our fluid, our gasoline, so to speak, or our fluid propellants in space, is that we've seen extinguishing as normal. And then in some cases, we've seen all of a sudden a reignition event.
Whoa.
So you think the fire's out, and then boom, it's back again.
Yeah.
And that kind of made our researchers scratch their head and opened up a brand new path of research on ISS that we weren't anticipating. But this kind of phenomenon, as they've determined, is called a cold flame.
Ah, yes.
So you have the ignition event, which is a thermal heat flame. The secondary cold flame event is a chemical flame. It's really a result of recombining of the elements in the atmosphere under those certain environmental conditions. And it's important to us to understand in space because, geez, you think you put the flame out, but what if your pressures and you've still got a little bit of mixing there?
Right. And is it invisible or is it a visible flame?
It's a visible flame.
Okay,
yeah.
it is. Okay.
And it shows up as this pretty toroidal cloud, a different color and everything.
Oh, okay.
However, you got a good point. There are some cameras in that facility that we use to look at different levels of the flame and what we can't see visually as well. And all those images go back down to the Earth, and the investigators, there's plenty of data to look at for those investigators. So,
wow.
Yeah, it's
That's
really
amazing.
fun.
So, I mean, these are just a couple of them, right? So just we're talking about the flame experiment, and we talked briefly about a life reproducing sort of phenomenon, but there's a lot going on. At any given day, how many experiments are going on the space station?
It's hard to say by day because some take longer than other, but we track them in a 6-month expedition period.
Okay.
And so there are at any one time over 6 months worth of about 250 different investigations that 6 crew members are doing on orbit. And they represent hundreds of scientists on the ground, by the way.
That's amazing.
Yeah, so that always gets me every time. Those numbers, 300 to 800 scientists on the ground every 6 months are getting their science represented by those 6 crew members.
Wow.
No pressure.
Yeah, for real.
On orbit.
So is it the astronauts that are working all these experiments, or are some of them kind of running on their own?
Both.
Oh,
so
okay.
Best bet is if you're going to create an experiment for station, if it's automated, all the better. And then if it's automated, you, as the investigator, could probably integrate your software into your computers and work with mission control to operate that. But
Whoa.
some of these things are so delicate, especially the living organisms, that they require crew time. And so we prioritize the science and make sure everybody's stuff gets done. And then we log it all, we capture it all, and then we turn out metrics to say, oh, this much got done.
It's just good science, right?
Yeah, it's just good science management too. Yes, that's right.
Right.
Yeah.
You gotta do that. Okay, so some of them do require astronaut time, and so I guess is this most of an astronaut's day is up on the space station? They are just going from research experiment to research experiment. Is that what's happening?
So it depends on the crew member, but
Okay.
it's the crew is scheduled, I think, for 8 hours of workday, and I think between all of the crew members on orbit, they'll represent anywhere from 35 to 40 hours. They'll get about 35 to 40 hours as the target done per week of science, but we have been averaging. We have had weeks of 70 hours of science done too. So it depends on the visiting vehicle frequency. Do we have new science coming or cargo that's being delivered? Do we have crew change out with new crew members?
Right, yeah, that can get in
Some
the
people
way.
are coming up to speed, and do we have an anomaly on orbit that they now need to go do an EVA? So all of these things need to be factored, so it varies. But anywhere, our goal is about 40 hours a week, but we have repeatedly hit at least 70 hours.
That's amazing.
Yeah.
And what's cool coming up here, we're going to have a lot more U.S. crew members, a lot more time to dedicate to some of these U.S. experiments, and that's is that going to skyrocket even beyond 70? Maybe.
Yeah, so we're
That's
looking
awesome.
at least 80 hours. That's like 2 full-time people working full-time science in a week, right?
Wow.
That's at least. So we're anxious to see what happens there.
Yeah, for real. Okay, so we got a lot of crew time. We got a lot of experiments. Some are running autonomously. So in general, we kind of hinted at this, but the space station, one of the main benefits is that you can take away gravity as in one of your experiments, and you can kind of mess with that. But what are some of the other things that makes the International Space Station such a nice place? The one that comes to mind is perspective, obviously. You're 250 miles above the Earth, so you can look down, so you got some observational things. But what other kinds of things, is good about putting research up there?
Yeah, so there's a few. Our Earth observation is a great example, but
Okay.
Then you get asked, well, what about the other satellites? Aren't there lots of other satellites observing the Earth?
Sure.
Well, yeah, but Space Station is a big satellite with lots of data capability and a trajectory that's different than any other satellite that we would call synchronous or geosynchronous satellites. So Station has a trajectory that can circle the Earth once every 90 minutes, and by the time it's through a complete rotation, I should say, it covers about 90% of the Earth's surface.
All
so
right.
90 to 95%, it can take images. That's more than any one satellite can do on its own. Plus, it's got human beings up there looking down and finding things happening that satellites, there's nothing like the human eye to see a flood or an oil spill or a volcanic eruption before anything else. So,
And that's happened before, right?
yeah, it has
definitely.
happened before. I heard a story of one of the crew members calling the USGS saying, I'm seeing a volcanic eruption, and they're like, no, they thought it was a hoax.
I think it was Jeff Williams.
Yeah.
What? Yeah, it was. Yeah.
Okay, we heard the same story.
Yeah,
Yeah.
and then they were able to actually communicate all that. He's like, hey, I think there's a volcano around today. Because he took a picture of it.
That's
It was cool.
right. And you can get the message out for those disaster response networks much more quickly.
Yeah.
But also, ISS is a huge platform for data. So if you've got something like the alpha magnetic spectrometer that's looking for dark matter.
Oh, yeah. Love that one.
The fact that it's a data hog.
Yeah.
It's looking for it's absorbing tons and tons of cosmic rays and sending, I don't even know what
Probably
bytes
a
of
gigatrigaton,
data.
yeah.
Gigatrigabyte. Yeah. I get teased for that one.
Wow,
But down
that's
to
awesome.
Earth, and only ISS can handle that kind of data and power demand to keep something up there for so long, to be looking for those kind of cosmic behaviors.
Wow.
But also, you can put experiments on the outside of space station to expose them to atomic oxygen or the ultraviolet radiation or the intense thermal swings.
Yeah.
We have put different types of materials out there before and get them home and look at the damage caused by external environments. And for example, one of those was a paint that's now been used on the Mars rover Curiosity, who's up there. It's protecting its critical power unit.
Right.
That was tested on station first.
Oh,
and
you put a bunch of
chosen.
paint
Yeah,
outside
you
and
put
see
some
which
paint
ones
outside.
did the
Yeah.
best. Oh, okay. Very cool.
And we can do that with spacesuit pieces and vehicle pieces. We've got stuff on paint on the SpaceX launch vehicles that were tested on station. And we've actually flown microorganisms on the outside of space station, too, to see how they'll survive in little types of endospores, to little, living organisms that go into hibernation, and then bring them home and find out what space did to them.
Whoa.
So it's got that external platform unlike anything other.
So I'm guessing bring them home is also a pretty good thing to do, right? Because you can play with something, but then you can also get it back down to Earth. Is that a
right.
unique capability?
Yeah.
Of
So the ultimate
ISS?
goal for any researcher is to get your sample home. If you're
Right.
a life scientist or a physical scientist, and that is enabled by the SpaceX vehicles. SpaceX can return samples.
Right. Okay.
But there are also other ways to get your data. So if you're a technologist or visual, if you just need images or video or zeros and ones
Just
data,
downlink it, right?
Downlink it from
Yeah,
station.
right.
And it's been those are ways to do it too. Now there was a technology experiment called Opals, which was tested on station. I believe it may have just wrapped up. They've met their objectives, but they're looking at using laser optical technology to send the laser data down in the form of high-speed lasers to the
Awesome.
ground. Yeah. And they used a couple of different ISS investigations as a way to pipeline that data and test it out. So
Sweet.
high-speed data transfer via lasers,
Yeah.
cool stuff. All that's happening at the same time.
Yeah, that's amazing. Okay, so there's a lot of these experiments in all different times, right? We're talking about observational research. We're talking about satellites. It's the benefit of covering the Earth. What are some of the categories of experiments that we're sending up there?
Yeah, so I'll start with the first one, which is my favorite, which are all the human experiments that happen.
Human,
There's nothing
okay.
like the crew members on station, right? They're
Yeah.
not robots. They are the human beings that will go and explore further. And so we've known for decades there are lots of changes that happen throughout the entire system. Because why? We're creatures of the gravity environment forever. That's
Right.
how we've evolved. So any system in the human body that you could think of has to adapt to the spaceflight environment. There's an effect. So we study the neurovestibular or the balance systems because they change. We study the bone. Since I was a kid, we've all known there's been bone loss if you don't use your bones. Think about why we have bones. It's because we have to stand up against gravity and our
Right.
muscles too.
Yeah.
If you don't use that in space, the body's pretty efficient at getting rid of it.
Yeah,
So-
your body needs to conserve energy, and if
Yeah.
it doesn't need bones, we'll just get rid of that. Put the energy
Exactly.
somewhere else.
So where do we get the energy? We tell our body we need energy through exercise. And
Oh,
so
okay.
we do resistive exercise and cardiovascular training on orbit to help mitigate that. And very interesting finding, we've been able to maintain bone mineral density now for the first time ever as a result of the work that we've been doing on station.
That's amazing. Over the course of a 6-month,
Over
even
the-
in
yeah.
the case of Scott Kelly, a
Yeah,
year long,
yeah.
right?
Wasn't as
So-
bad as it could have been.
Yeah.
So kudos to us for that.
Very cool.
And the immune system. So anything in the human body, right? Other than the human body, there are changes in biology, the living systems the fruit flies, for example, are model organisms that are used in the laboratories. We can look at changes in their genetics as a result of spaceflight, what their babies would look like or how they would behave. We can send up tiny little worms that are called C. elegans and look at how they behave or even infect them in space with
Whoa.
a certain type of bacteria.
To see how the
to
immune
see-
system works
yeah,
or something?
well, you can study their immune system, but you can also try to figure out what makes that bacteria aggressive.
So study the
why
bacteria.
does it infect you in the first place?
Wow.
What is it? So we've actually found that microgravity has upregulated, is what we call genes, to make certain bacteria more yucky and make you sick quicker.
Huh.
All kinds of, we send up rodents to look at the behavior of some of the systems in mice. And so any living system, the microbiology component of it is fascinating too. We sample the environment on a regular basis, the air, the water, the surface, to look at any new findings in bacteria that or fungi that might be showing up that
within
are
the environment,
wacky?
within
Yeah.
the habitable environment of the space station. Yeah.
And especially since we see that our crew members have evidence of a suppressed immune system, how does that, if anything wacky shows up, how is that going to affect their immune system?
Yeah.
So the interesting microbiota is really fascinating, those kind of studies. But we also do technological studies. So technology, we use space station as a platform to test what we want to use to explore further. So for example, the big one right now is Beam, right? The big inflatable one that's up there right now.
That's really cool.
That's really
Expandable technology,
Yeah.
expandable modules. I love that.
And
It's
that's,
like
It's huge.
Yeah, it is. And you can get them to be way bigger. That's the whole, the value add of that, right? Is you can launch something with a similar weight, but just kind of pack it down and then expand it in space so you have way more volume. That's awesome. You can make gigantic space habitats with that. That's really awesome.
It's got great potential. So it's one of our technology development initiatives. But we also test out new gas analyzers or air monitors up on orbit, or ways to better service satellites that end up out there dead and were never intended to be serviced. But if we want to go to Mars, for example, maybe we want technology to service, stations in between us and Mars.
Oh,
right?
yeah.
So you've got these little waypoints that give you extra fuel or extra food or something.
Like space gas station / convenience stores.
Yeah, who knows? So we do some of those technology evaluations to create new tools and processes that could possibly get us there too. So technology, but we also have a lot of education that happens.
Very important.
Yeah, we've got students setting up their own experiments in lots of different opportunities on ISS through nanoracks and student organizations. I mean, high schools are going fundraising, their own money to send their own experiments on ISS. It's that accessible.
Wow.
Yeah,
very cool.
And we've had fifth graders do that too. There are a couple of formal programs. One's called the Sally Ride EarthCam.
EarthCam, right.
EarthCam,
Yeah,
managed out of the U.S. Space and Rocket Center in Alabama, where if you're interested as just a regular student, you just go register with that program and you say, I want the space station to take an image of X marks the spot, and they will put you in queue, get that image, and contact you when it's available.
Wow.
And, ham radio, if for those of you who like, using the ham radio, if you're a ham radio specialist, there are certain opportunities to call the space station crew members on a ham radio and just to ask questions. So that's all ongoing. And some of the best experiments are student experiments because they ask the weird questions that, the what if questions, they're still in that phase of early discovery.
Right.
Some of our established researchers have their own path to research and their own questions they want to ask that helps benefit the research they're doing, and which will ultimately get to us here on Earth too. So there's lots of opportunity. And in fact, even the researchers who don't have a goal of education, there's always a student involved one way or another, whether it's undergraduates or graduate students crunching numbers or has a dissertation or a thesis or something associated with that. So we are always interacting with students.
Wow.
So lots of education. The physical sciences, anything from flames to fluids to tiny little particles called, colloids in a suspension of fluids.
Oh, okay.
Complex fluids or non-Newtonian fluids or solids, alloy behaviors. Can you melt two materials together and create something new? We've got capabilities for those kind of metals on space station too. We've got furnaces.
Ooh.
We can levitate materials too.
What?
Yeah, you can levitate them on ISS. And basically you have containerless processing, so you can process materials, metals, or solids without it ever touching a container.
Doesn't have to touch anything.
Yeah.
Cool.
So all the kinds of sci-fi, wacky stuff you can imagine happening in microgravity, we're almost doing almost all of it.
Yeah.
We're doing a lot of cool stuff. But.
Well, 250, I mean, it's got to come from somewhere, right? So you got from every different type of science. That's just, it's amazing. Well, other things that you can accomplish. And I'm excited to see what they're all going to do when all the 4 crew members are up there,
and
too.
they're never bored, I'm telling you. Those guys are never bored. And the interesting thing with the astronauts is, too, they take personal ownership of getting this stuff implemented. Like, they're trained on the research. They know they're the proxy scientists for the guys on the ground, the guys and the gals on the ground. Yeah. And they are serious about getting it done.
That's awesome.
And then they take joy in the work they do, too. And oftentimes we'll ask, can we do more of that? Can we do, more of this, more of that? So,
very cool. Yeah, I think one of my favorites was when Kate Rubins did the DNA sequencing, right? Because she has the science background, and when she did, it was just cool.
Yeah, and the interesting about Kate, too, when she came back, she is sharing all the knowledge with those of us on the ground who can enable us to do even more of what she did. It's like, wow, why didn't we think of this? Well, we think we thought of this before, but Kate comes back and she's like, no, seriously, you can do it like this. This is exactly how I did it.
Well, she did it right.
Do it in the future.
She has the perspective.
Yeah.
She was the one running it.
So unique. So it's such a resource we're excited about.
Awesome.
Yeah. Good stuff.
I love it. DNA sequencing, though, that's a cool one. That one's the purpose of that is just to make real-time decision making, right?
Yeah.
So you can understand how genetics change over time, but real time. You're getting data. That's awesome.
I mean, on Earth, it's just the whole DNA genetic sequencing, you can't even keep up because technology and processes are evolving so quickly. If you've kept up with any of that stuff, the human genome and new findings in DNA and RNA and all the things in between. I mean, even since I've graduated, there's new stuff, and that I don't even know. But so NASA now is on the cutting edge of keeping up with what's happening on Earth, or at least watching. ISS is watching and trying to figure out what's important for researchers and trying to bring that to the laboratory to invite those researchers to now do this in a microgravity environment. So there's interesting changes that can happen to your genetics throughout your lifetime that affect your genes inside of you as you live, and then you could pass on to your children. And
they change naturally, or they change because of influences?
It's called epigenetics because of influences.
Oh, influences.
External influences.
Interesting.
It's really interesting.
Wow.
Even the stress of an environment can change some of your genetic outcomes and pass on to your children.
Oh, no way.
Yeah.
Okay, so I got to remember to relax.
Could be one. Relax, dude.
Yeah.
If you've got a future with children, y'all need to relax. Try to chill.
Yeah.
But microgravity could be one of those. And what does that all mean? Well, I don't know. If you can do it real time in space on ISS, and you can look at data from DNA real time, well, you'll know what it looked like yesterday. Now you'll know what it looked like today. Those are all tools that researchers are interested in for lots of different reasons on Earth. But,
that's amazing.
Also, what happens with our crew members is we stay up longer and longer. We want to go to Mars. What happens to our genes?
Yeah, you got to know all that stuff.
Yeah.
I mean, there's a lot of different experiments going on, and like we talked about. But how is everyone getting them on the space station? I know there's an organization called CASIS, right?
Yes.
They kind of help with that.
Yeah, they kind of help.
Okay.
They're the big help.
They're
yes.
the big help. Okay.
Yeah. So certain parts of the United States assets on the space station are considered a national laboratory, a United States national laboratory. That's a designation that maybe 12 or 13 other laboratories in America are given, and that means they're special. There's something unique about them that nobody else can offer. But it also means that now we have one in space. And it's the National Laboratory on ISS, and its unique resources are everything I just explained.
Right.
But also now it opens up access to non-NASA users. So researchers from other government agencies, researchers from academia, researchers from commercial industry, students, you off the street who has a really great idea that's feasible. It's open to all of you to propose your research to get on the International Space Station. Now, the CASIS is the Center for the Advancement of Science in Space. That's
Love acronyms.
Yes, we have acronyms probably within an acronym.
But it's an organization, right?
Yes, they're an organization that manages that national laboratory component. Okay. So when you have a great idea, you go to www.iss-casis.org. Okay. And you find out there's a flow. You get into the research process, and you propose your ideas. And either CASIS has opportunities open, or you propose ideas, and they're looking for all. I hate the cliche, best and the brightest, but it's true. That's what we want. Like I said, to be able to use this laboratory now is like more important than ever.
Right.
And a lot of people don't even know that they can do this. They think space is so inaccessible. And I know. I go around and I talk to researchers, and the look on our face is like you're looking right now. You're like, what? It's so accessible. What do you mean? I can just, come up with an idea.
Well, how about this? How about we do a whole podcast episode on ISS research and tell them how to get there? That would be cool.
Yeah, we can invite some CASIS people.
All right, somebody write that down.
We got this. Action to us. We've got an action. Great.
Very cool. Okay, so they go through CASIS, and CASIS makes it easy for them to get it on the station. They'll walk them through the whole process. And they can use the national lab for whatever idea they have.
That's the whole point.
That's awesome. So, I mean, when you're talking about all these different research, a lot of it, and like you said, a lot of them, we want to go to Mars. So we got to figure out, we got to prepare, what's the human body going to do on long duration space flights for when we get there. But, there's got to be some components that are coming back down to Earth, right? So what we do and learn comes back down, and we can put it into our everyday lives, right?
Yeah. So one good example of that is that, when we launch our crew members to ISS, not every single one of them is a medical doctor. And so what if someone hurts themselves or gets sick on orbit? How do we assess that from the ground? Well, we have an imaging capability on orbit, which is the ultrasound. And that's really the only imaging capability we have. We don't have x-rays or any of that stuff. And so now the goal is to use the ultrasound. Now you got to train non-clinicians to use use this clinical tool to
Yeah.
assess, right, and send information down to the docs.
Because they don't, yeah.
Because they can't assess on orbit.
Right.
And so we've had an ultrasound that we sent to ISS. It was slightly modified with some software. We used it to train the crew members up before they launch, and our unique software and training programs were so widely recognized now by the Academy of Surgeons on the ground that it's being taught to up-and-coming surgeons. Like our training program and our software systems are being taught to new clinicians and to use that on the ground. Because when you think in terms of telemedicine, you can deploy these ultrasounds everywhere, and it is being done that way. More and more telemedicine's happening, right? As for our troops who are in a place where they can't get access to hospitals or to communities that don't have access to clinical facilities.
So a doctor comes to them remotely, sort of.
Remotely. So
Yeah.
the idea is now you've got this ultrasound out there. You've
Okay.
got someone who's been trained up on how to use it, even if they're not a doctor.
Uh-huh.
You've got people who can use it, send the information back to the doctors wherever they are, and the doctor can make a diagnosis. So those kind of benefits we don't hear a lot about because they don't affect, ultrasound doesn't affect our everyday lives.
Yeah.
But they're also because out of pure basic need, we started looking at specific tissues on ISS that you would not normally use an ultrasound to look at. You would use something like
Oh.
an X-ray or an MRI. But we have gotten need-driven and so uniquely useful at this ultrasound technique. It's
Yeah.
now driving clinical decisions on when to use an ultrasound versus an MRI versus an X-ray and all these different components. So new techniques coming out of ultrasound.
So not necessarily in your house a benefit, but
No.
but your health.
Your
the
health,
doctor does a
yeah.
better job.
Yeah,
Yeah,
maybe
that's
the
cool.
doctor can order an ultrasound instead of an MRI and
Yeah.
get you some better results or different results or faster results. Who knows?
Very cool.
Another benefit is that this laboratory, this set of laboratory scientists have used space station, again, thinking about the fluid behavior in space, to advance some of the treatment tools that they're going to design for possibly treating certain diseases, including cancer. So this team sent up, they're trying to improve on what's called micro balloons or micro encapsulation. So you take this tiny little ball that you've created and you put a bunch of chemicals in there, whether it's treating cancer chemicals or some good agent where you want it to go. You target it directly to the point, maybe it's a tumor, and you treat it that way, rather than maybe a systemic effect of chemotherapy. So these little micro balloons can be delivered anywhere in the body, do pretty much whatever you tell them to do. But it's not perfect. We've never, ever in the history of micro encapsulation been able to use it clinically. So this, because of different reasons, it's just not effective, it's not targeting right. So this group sent a new machine to space station, tried to leverage the microgravity environment to create new microballoons based on different fluid behavior, and got a result that showed improvements in laboratory tumors. Now, this particular group is in the path of getting to FDA approval for use as a treatment of cancer, but we're not quite there yet, right?
Okay.
And so we're not saying station's going to cure cancer.
Yeah.
But some of the techniques that have come out of space station are on the path to FDA approval, and we may see some of that coming out in the next several years or so.
Well, very important step.
Yeah, and those
Yeah.
kinds of things take time too. So
Right.
that's another thing to remember. We're still seeing results from Apollo come in, right?
Oh, wow.
And when you talk about really critical results and benefits to those on Earth, any laboratory could take a while, depending on whether you've got FDA approval or whether it's a quick turnaround type of investigation. Some of them go quicker than others, and the life sciences are typically the longest because it's so complicated.
Yeah.
Yeah,
You're
but
dealing
we
with life.
Yeah. But we, in the meantime, if you go to www.nasa.gov, I think it's /station benefits, we have a whole page dedicated to these two examples plus tons of others that you can learn what has station done for me, like in my daily life now.
Cool.
And everything from brain surgery robotically, because it was designed based on the Canada arm that we use on the space station to identification of lost boats, ships on the ocean, thanks to some of the signals that space station was able to pick up. So there's lots of good stories there.
Wow, that's amazing.
Yeah.
So a lot of things being brought down to Earth to benefit us, like to benefit humankind, and that's a very, very important part of ISS, right? So that's what we like to say: off the Earth, for the Earth.
Yeah, that's right.
That's cool. So I mean, going away from Earth towards Mars, what are we learning? I know we're talking about the human body and some other stuff, but what are we learning specifically on ISS that's really going to help us get to Mars? Boots on the ground.
Yeah, so a couple of things. We've got technology development, miniaturized, most efficient systems for maintaining humans. Everything evolves around maintaining the humans, right?
Yeah,
we
right.
are the ones going to Mars, so every system needs to cooperate with that. And so keeping humans alive, how much food does a human need? Can we miniaturize it? Is it affected by radiation? Can we extend shelf life of that, plus pharmaceuticals? What about all the medical capabilities? How are they going to be trained? Let's see, radiation effects, how our genetics change. Behavior even of one that you sent me an example on, which was the Strata investigation. I thought that was cool because I was like, what is that? But no, that's studying how dust behaves, or regolith dust behaves in a microgravity environment. Well, yeah, right? That's a good thing to know before you go to Mars.
People are going to interact with it, right? So you got to know what it does.
You'll land there. And I hear from stories about the moon, it's pretty, it's a driver. It is a major force to contend with. So any system involving the humans, any system involving air, water, recycling, spaceship Earth. That's what we're doing on the International Space Station in every different direction.
That's amazing.
Yeah.
It's cool. There's
lots.
It's going thinking about Mars. We're thinking about other planets. What we're learning. The regolith on the moon obviously is a consideration. That's why we put it on ISS. Bring it back down to Earth. This research goes everywhere.
Yeah.
So that's amazing.
Yep.
So is there anything that we've investigated on the ISS that we didn't really know, or some kind of story where there was something that was discovered through trying to discover something else, or something new that has come up?
Yeah, I think one of the most intriguing things to me is the fact that as our crew members stay on orbit, their bodies start to exhibit lots of symptoms. I would call it symptoms, but projections of what we see in our aging population on Earth. And they do it at a very accelerated rate. So there's a corollary between what we see in the human immune systems, the bone loss. The bone loss happens at a rate of, if it's not treated, at a rate of a postmenopausal woman, or even faster, which is 1% to 2% per month.
Just from being
lost.
in space.
Yeah.
Wow.
Yeah, and the immune system starts to a lot of the changes in the tiny molecules of the immune system starts to represent what we see in aging populations. There's also wound healing that it seems to be a little bit slower in space. So I keep going back to the human body because to me it's the most fascinating, and everything we do is because we want to explore. So some of the most interesting findings come from that, and especially the aging population. Now, when we figure out how to treat our astronauts, or I wouldn't say treat, but mitigate some of the effects that we see with spaceflight, those have been able to be applied to the aging populations here on Earth. So, for example, bone loss I mentioned, but it's because they're doing their resistive exercise. That's because they're taking their high doses of vitamin D and they're eating all their calories. Well, before you're osteoporotic and you get to just that point, your doctor's already telling you, well, we think resistive exercise is a good idea and calcium and vitamin D. But we can show on space station in a short time.
You have the data.
Yeah, the data. And so it's amazing to me how the crew members are an accelerated model for everything that we are interested in, disease populations or aging populations on Earth.
Wow.
And they're great because you know what their history is. So they're kind of a clean model to look at.
Oh, wow. I mean, that's kind of, a lot of astronauts describe part of their job as being guinea pigs, right? So, because like you said, human body is one of the top research investigations on the International Space. You want to know what happens to the to the human body over time in space when it's in space for that long.
Want to
Because
get past?
we're in a time where this is a normal thing, right?
Yeah.
We've had anyone born past the year 2000, right, has
Right.
never known a time when there hasn't been someone living in space.
Yeah, my daughter's 10. She's like, what do you mean? What? Yes, of course there are people living in space. There's always been people living in
Isn't
space.
it weird that that's like a normal thing now? It's just like, oh yeah, there's people in
And
space.
the thing is, we're going to be done sending robots. Not done, but we're going to get past just sending robots to Mars. It's the human experience. So we're
Yeah.
very complicated machines.
Yeah. So to you, what is the benefit of sending humans to Mars?
I think it's that personal judgment.
Yeah.
It's something that no amount of circuitry programming, at least in my mind, I'm not a science fiction reader, so maybe someone can correct me, but there's nothing like discernment from a human being, making a judgment call. That could be hard. It could be a little bit easier. It could be tricky.
Yeah.
Human in the loop is the cliche that I hate to use, but it's true. There's nothing like people.
We could take, that's what happened when we landed on the moon, right? You can take pictures of the moon all you want.
Yeah.
We actually had a couple missions around the moon. We had robotic missions
That's
land
right.
on the moon before they even
That's
got
right.
there. No one cared. But once as a human actually set foot, we can all of a sudden we were part of the experience. We could
Yes.
all share.
And
so.
coming back is a big part of it because
Yeah.
those people come back and they share their unique experiences and they inspire others and the lessons learned, and we want that information back. That becomes a national resource.
Yeah.
So yeah, there's nothing like it. It's a really good example.
Yeah. I just can't wait. I can't wait till someone lands.
Someone's gonna do it.
I want to hear their story. Someone's going to do it, right?
And ISS will help get them there.
Yeah, absolutely. So what's one of your one of their top investigations going on the International Space Station, either right now or in the past? Something that you just think that really stands out, and it could be a part of the human body, but anything that's really just really stuck with you, or you always go back to or refer to.
Man,
It's a hard one. It's loaded.
Yeah, I'm going to try to get off the human research one and talk about AMS, the alpha magnetic spectrometer.
Oh, right.
I am not an astrophysicist, but again, it's searching for these cosmic particles, this dark matter, this dark energy. I think I read at some point that everything that we perceive is only 5% visibly. 5% of what's really actually out there. So if we're only seeing 5% of what's really out there,
Can't even think.
what is in front of me right now?
Right.
That we can't see. And so I know it's more complicated than that, but
Right.
philosophically, I think AMS speaks to me in terms of what are the origins of the universe? Where do we come from?
Yeah.
And
I think those are really the ultimate questions.
Yeah.
What is the origin of the universe? Where do we come from? Are we alone? These
Yeah.
these big questions.
And we humans are designing big tools like AMS to try to find these quirky things. They're called quarks or neutralinos or things that we think exists and we can replicate on Earth. We can create them on Earth, but how do they exist naturally? And then if they do exist, that proves some theory. It helps prove theories of where we came from. So that whole very complicated designed instrument is all just an extension. It's a tool that extends our human senses in a way that we can't do. And so that just fascinates me as an extension of us.
I think the International Space Station and AMS, all these things, the fact that these exist, the fact that they're actually up in space, that we are actually doing them, that we ask these questions and pursue them through technology, things that we invent and we come up with an idea in order to observe it. It just proves we are very curious beings. We really want to know what's going on, and we will do
capable.
anything and capable. Curious and capable. Very
We will
good.
stop at nothing.
We will stop at nothing.
Not even budgets.
Oh my gosh. It's just a fascinating concept.
I'm really lucky to be working where I am now.
Yeah.
I would have never dreamt up this career for myself. Quite honestly, it's everything I've ever loved. I get to do every day.
Yeah.
So I couldn't have created it. I'm just really fascinated. Fascinating place to work.
Yeah, it really is. It really is. The things we have to think about all day are just, it's just, you think about space. You think about, what can we do? Where are we going to go next? How are we going to get there? It's just
How do
very
we
cool
make the
question.
most out of what we have?
Oh, man. I wish we could do a 2-hour-long episode, but Tara, I'm sorry. I think that's about all the time we have. So for the listeners, stay tuned till after the music here and learn about some of those sites. We're going to reiterate those sites that Tara was talking about so you can go visit them, especially if you're a researcher listening to this podcast and want to know where to submit your research and actually take it to space, go to the International Space Station. It's very, very cool, and learn some of those benefits. Some of the ones we kind of skimmed over them because we really do have a short amount of time. But if you really want to learn about them, just stay after. Yeah, for sure. So Tara, thanks again so much for coming on the show. I feel like we have a good grasp of. I mean, we have
a place
I
to
wouldn't
start.
say good grasp, but at least a good place to start. An overarching knowledge of all the research going on aboard the space station. But it is very continuous, and thank you for coming.
I
on
hope I've
today.
inspired a couple of you out there. So
You inspired me,
great.
so I think it was worth it at least at that. So thanks
you.
again.
Sure.
Houston, go ahead.
Stop of the space shuttle.
Roger, 0J, and I feel fine.
Shuttle has cleared the tower.
Became a peace for all mankind.
Actually, a huge honor to break a record like this.
Not because they are easy, but because they are hard.
Houston, welcome to space.
Hey, thanks for sticking around. So today we talked about space station science with Dr. Tara Rutley. And if you want to know what's going on aboard the space station right now, just go to nasa.gov/ISS. But we were talking mainly about space station science. If you want to go there, just go to nasa.gov/ISS-science. That's actually where you can find all the research that's going on aboard right now. We also sort of alluded to some of the benefits that are going on station that you can bring down right to Earth. So if you go to nasa.gov/station benefits, that's the one where the experiments that we're doing aboard the International Space Station, the ones that actually help us out here on the ground. And you can also find a lot of the stuff on the Spin-Off magazine. Those are some technologies that have been spinned off from NASA technology right here into our everyday lives. And it's really cool. I would definitely recommend checking it out. So if you're a researcher or a student and you want to send some of your research aboard the International Space Station, just go to your favorite browser and just type in CASIS. That's CASIS. Or you can go to www.iss-casis.org. One of those will take you to the organization that will actually help you get your research aboard the International Space Station, and it is really cool. You can get some really cool stuff when you send your experiments aboard. We have students that do stuff like one of my favorites is spheres. They're actually tiny little robots that students can actually program controls, and then they actually fly around the inside of the space station. You can get some great imagery of your experiments there. So if you want to follow us on social media, any of the International Space Station sites will help you out. There's the International Space Station Facebook page. On Twitter, it's @space_station, and Instagram is @ISS. But we also have research accounts too. Just type in ISS Research. I'm pretty sure they're verified on all of those different platforms, Facebook, Twitter, and Instagram. Use the hashtag AskNASA on your favorite platform to submit an idea to the podcast. Maybe you have a question, or maybe you have an idea of an episode that we should do, and make sure to mention it's for Houston We Have a Podcast. So this podcast was recorded on June 21st. Thanks to Alex Perryman, John Stoll, Greg Wiseman, and Dan Hewitt for helping to set up. And, of course, thanks to Dr. Tara Rutley for coming on the show today. We'll see you next week.